we have a double sum. The first one is from I equals 1 to 5, and then sum from j equals 1 to 6 of 2I plus 3j. First, we're going to deal with the first sum here, going from j equals 1 to 6. So I here is going to be treated as a constant since j is our variable here. So whenever you have a sum of a constant, let's say from I equals 1 to n, this will be the constant times the numbers from 1 through n, the total numbers from 1 through n, which is n. So this will be c times n. Now for this one, 2i is the constant, and how many numbers are between 1 and 6? Well, clearly there's 6 numbers, so it'll be 6 times 2i, and then plus, we want to sum 3j from 1 to 6. And because the 3 is a constant here, I can just pull it out, pull outside of the summation. And so at this point, I can multiply 6 times 2i, and then we know that in general, if I go from I equals 1 to n of I, this is n times n plus 1 over 2. For us, n is going to play the role of 6, so it's 6 times 6 plus 1 all over 2. Simplifying it more, this is 12i plus, now 6 over 2 is 3, and 3 times 3 is 9. 6 plus 1 is 7, so 9 times 7 is 63. So I can break this up into two separate sums, and the 12 can be factored out. Now I can use the formula here for the sum of I, so that will be this formula up here, which is 5 times 5 plus 1 all over 2. And then this is a sum of a constant, so it'll be the constant times the number of numbers between 1 and 5. So this will be 12 over 2 is 6. So it's 6 times 5 is 30, times 6 is 180. And then 63 times 5 is 315. Adding this up, we get 495 as our answer. Let's look at another example. Sum from I equals 1 to 3. Sum j equals 1 to I of I plus 3. I and 3 do not depend on j, so you can think of this as just a constant. So remember we said that this is just a constant times n, which for us, n is going to be I. So it'll just be I times I plus 3. And because we're only going from 1 to 3, it's probably better not to use any formulas since this will be quick. So we'll plug in I equals 1 first, and then move on to I equals 2, and then move on to I equals 3. So we have 4, 10, 18. So this is 32. The next one, sum from I equals 1 to 5. Sum j equals 1 to 6 of I squared minus j plus 1. Here, the I and the 1 are going to be the constants, so that one we're going to multiply by 6. And then I'm going to factor out the negative, and then we're just going to have the sum from j equals 1 to 6 of j. Now we're going to use the formula, yeah, we're going to end up factoring out the 6 in just a second. So this formula will just be 6 times 6 plus 1 over 2. Now I can simplify this. So 6 over 2 is 3. 3 times 7 is 21. So what I'm going to do, I'm going to distribute the 6. So let's take like an intermediate step here. This will be the intermediate step. And then I have 6i squared and then minus 15. So break this up into two separate summations, and we'll factor out the 6 and the negative. So this will be 15 times 5. And for this one, we can use a formula. So in general, the sum of I squared from I equals 1 to n times n plus 1 times 2n plus 1 all over 6. For us, n is going to be 5, so it's 5 times 5 plus 1 times 2 times 5 plus 1 all over 6. 6's are going to cancel. We have 5 times 6 is 30 times 11 is 330 minus 15 times 5 is 75. So this is 255. Okay, last one. We're going to flip these sums. So last problem we did I equals 1 first, but this time we're going to do j equals 1. So the j and the 1 are going to be constants here, so I can break this up. So negative j plus 1 times a constant. So here it's going to be 5, and then plus the sum from I equals 1 to 5 of I squared. Now for this one, I equals 1 to 5, I squared, that's the 5 times 5 plus 1 times 2 times 5 plus 1 all over 6. So that'll be 55 since the 6 is canceled. So I have negative 5j plus 5 plus 55, that's going to be plus 60. And I can factor out the negative 5, go from j equals 1 to 6 of j, and then the 60 is a constant, so I could just do 60 times 6. And now I'm going to have 6 times 6 plus 1 over 2 plus 360. Now 6 over 2 is 3 times 7 is 21 times negative 5 is negative 105 plus 360, and that's going to give us the same answer of 255.